without the integration sign. So what do we have here? We got x squared minus 1 all over x times 1 minus 2x all squared. So now, what is the degree of the denominator? We just worked it out now. We know the numerator was of a second degree. The highest power there was 2. The denominator, what is the denominator? If we have to mentally multiply this out, what is the highest power of x here?
3.
3. Okay. Because this is going to be minus 2x all squared. So it's going to be an x squared multiplied by an x, which will be x to the power 3. So therefore, it's third degree.
8.
So what does that mean? That means you're going to have 3 fractions. You'll have 3 constants. What do I mean by 3 constants? I mean A, B, and C. If the highest, the highest power was a 5 there, then it's going to be A, B, C, D, and E. Okay, so the degree of the denominator will determine how many fractions you have. Right, so the factors involved here are x, that's one factor, and 1 minus 2x all squared. So we start with each factor. This is x to the power 1. If there's no exponent, it's a positive 1. Right, so now we can write this as a all over x to the power 1. We're done with x there. Now we need to deal with the factor 1 minus 2x all squared. So how do we deal with this? If it's ax plus b to the power n, you always start with 1, 2, 3 and you reach n. That means if it's a 2, you're going to start with 1 and you end at 2. If it's a 5, you're going to start with 1, so it's going to be 1, 2, 3, 4 and 5. Right, so this is going to be plus b all over 1 minus 2x to the power 1 plus c all over 1 minus 2x all squared. We're done now with the first part. So it was a third degree. There's 3 fractions. There are 3 constants, a, b, and c. So now the next step is to find the LCD on both sides. Get rid of the denominators. Right, the quick method here to do that is multiply by the denominator on both sides. So I got my x squared minus 1 all over x times 1 minus 2x all squared. I'm going to multiply by this denominator here on both sides. So that will be x times 1 minus 2x all squared. I have to do it on the left and on the right to all terms. Right, so I multiply by the denominator on the left hand side. On the right hand side I do the same, x times 1 minus 2x all squared. That's x times 1 minus 2x all squared there. X times 1 minus 2x all squared. So now, on the left hand side, the denominator must cancel perfectly. If it does not cancel, you multiply it by the wrong factor. Alright, so on the left hand side, you can see x and x cancel. These two cancel. What remains is x squared minus 1. Here it's just simple cancelling of common factors here. Alright, so x and x will cancel here. You end up with a multiplied by 1 minus 2x all squared. Here 1 minus 2x will cancel with one of the 1 minus 2x's on the top. So you are left with b times x times 1 minus 2x. You follow? You can do that mentally. Plus c, it's clear that these two will cancel. Alright, so you're left with c times x. Now, at this stage, there must be no fractions. If there's a fraction, you made a mistake. So now, we need to work out these 3 constants. We need to work out what is the value of a, B, and then C. So now, how do we do that? If you remember from N5, we use the method of substituting values there. So if you can remember, what's the best value to substitute? One of the two best values to substitute at the moment. 0. Okay, now some of you did not realize that the people who are saying 0, how did they know that 0 is one of the best values to substitute? Because if I substitute a 0, we're talking about the right hand side. Here, specifically 0 times everything here will be 0, 0 times anything here will be 0. So we'll only be left with A, which we can work out. After we're done with 0, what's the next best value to substitute here? What's the next best value? Can we get a 0 results?
1 over 2.
1 over 2. Yes. If 1 minus 2x is equal to 0, so then 1 is equal to 2x, x is equal to 1 over 2. You look at this here, and you check. So how are these people getting it? And all they did was, here it's clear, you can see 0 times anything will be 0. But here, can 1 minus 2x equal to 0? Yes, it can. What is the value of x here that will result in a 0? All you do is you solve for x. 1 is equal to 2x, so 1 over 2 is equal to x. Alright, so let's start with the first substitution. On the left hand side, we write down let x equal to 0. So wherever I see x, I'm going to replace it with 0. So that will be 0 squared minus 1. This will be a 1 minus 2 times 0 all squared plus b times 0, 1 minus 2 times 0, and that's plus c times 0. So here 0 squared is 0, 0 minus 1 is minus 1. Here minus 2 times 0 is 0. So that's just a 1. 1 squared is 1. 1 times a here will be a. Okay. Here 0 times everything will be a 0. 0 times anything here 0. So you can see why 0 works nicely here, because it gives you the answer in one step here. So a is equal to minus 1. So what is the next value that we chose?
Minus
1 over 2. Right, so let x equal to 1 over 2. So on the left hand side, wherever I see x, I will substitute 1 over 2. So that will be 1 over 2 all squared minus 1. This will be 1 minus 2 times 1 over 2 all squared there, plus b times 1 over 2, and then you got 1 minus 2 times 1 over 2 here, and then the last term is plus c times 1 over 2. Right, so here on the left hand side, we got 1 over 4 minus 1. So here, wherever you had this factor of 1 minus 2x, you don't even have to think too hard. What will the result be here? The result will be 0. That's why we let x equal to 1 over 2. So wherever we had the factor of 1 minus 2x, you know this is going to be a 0 here. This will be a 0 there. So here, it's just plus 1 over 2c. Right, so it's simple. We can just work this out. 1 over 4 minus 1. 1 over 4 minus 4 over 4 is minus. 3 over 4 is equal to 1 over 2c. So therefore, c will equal to minus 3 over 4 divided by 1 over 2, which will equal to, but you don't have to go and show all working here, you can just use your calculator. So that will be, let's see, what will it be? Minus 3 over 2, am I right?
Yeah.
Yes, that will be minus 3 over 2. Simplify. So now, we ran out of values to get a result of 0. Okay, there is no other number here to substitute that will result in a 0 for us to get our answer in one step. So now, we have to substitute one more time because this is 3 fractions, 3 constants, 3 substitutions. So what? Give me another value to substitute. You can substitute any value, it doesn't make a difference. Choose an easy value, but don't substitute a very high value. Easy value, let's take 1. Okay, let's take 1. So let x equal to 1. So on the left hand side, we will have
x squared minus 1
x squared minus 1, so that's 1 squared minus 1.
equals
That will be a into 1 minus 2 times 1 all squared plus b times 1, 1 minus 2 times 1, and then your last factor there, your last term, c times 1. Alright, so here 1 squared is 1, 1 minus 1 here, 0 there. So here,
a
we got, be careful now. You got 1 minus 2, which is minus 1 squared is 1. 1 times a here will be a. Here, 1 minus 2 is minus 1. Minus 1 times 1 will be minus 1b. And this is just
c
plus c. So we already know what we found a. We found c. That means we can substitute for a and c. And then we will find b. So let's do that. So that 0 is equal to
and c
a, which is minus 1. Okay. Minus b plus c. What was c? Minus 3 over 2. So if I take minus b to the left, so it will be b is equal to minus 2 over 2 minus 3 over 2, which is minus 5 over 2. Minus 1 minus 3 over 2. Minus 2 over 2 minus 3 over 2, which is minus 5 over 2. So now, let's substitute. Alright, so therefore, x squared minus 1 all over x into 1 minus 2x all squared. I'm going back to the step here now. The first step. I'm going to substitute for a, b, and c. So what was my a here? A was minus 1. So it's minus 1 all over x plus b. What was b? Minus 5 over 2. All divided by 1 minus 2x plus c all over 1 minus 2x all squared. What was c? It was minus 3 over 2 all over 1 minus 2x all squared. So I substituted. Now I can integrate this here. So you need to remember your type A and B. And let's put our integration sign in. Now, when you're putting your integration sign in, now you are preparing these fractions, or if it's not a fraction, it depends on whether it's type A or type B. You're going to rewrite it in its standard form. So take your constant, so that's minus 1 times 1 over x dx here. You got another constant, positive times negative here. So that's minus 5 over 2 times 1 over 1 minus 2x dx. Here, positive times negative, that will be minus 3 over 2. And now, here, do I leave it as a fraction? No, this is not type B, this is type A. It has an exponent of 2, so I will take this to the top. It will be 1 minus 2x to the power minus 2 dx. So now, here, that's straightforward here. It's up to you. Do you want to use your U substitution or inspection? But I'm going to leave you to do this first because I'm going to use inspection on the board and then you will get confused. So you'd rather use your U substitution first. Let me give you a few minutes. Okay, so we had to integrate here. I told you, you can use your U substitution so you won't get confused when I'm doing inspection. Alright, so now here, this is type B. Derivative of x is 1. Exact derivative there, so that's going to be minus ln of x. Okay. Here the derivative of 1 minus 2x is what? What's the derivative of 1 minus 2x? Minus 2. So I multiply by 1 over minus 2 there. Here the derivative of minus 2x is minus 2 again. So I multiply by 1 over minus 2 there. I'm using the method of inspection. You must get the same answer using substitution. Alright, so here this will be plus 5 over 4 ln of 1 minus 2x. You got that? Right, here this will be plus 3 over 4, and this will be 1 minus 2x minus 2 plus 1, that will be minus 1 over minus 1 plus c. Obviously this can be simplified further, so let me just go to the last step. Minus ln x plus 5 over 4 ln of 1 minus 2x. Positive times negative here. So that's minus 3 all divided by 4, and that's 1 minus 2x. I'm just simplifying. You got that using substitution? The numerator is of a 3rd degree, denominator 4th degree, so therefore I'm going to have 4 fractions. Okay, let's start with the factor of x minus 1 all squared. So this will be a all over x minus 1 to the power 1 plus b all over x minus 1 squared plus c. We're done with x minus 1 now. Can you see that? Now we deal with the next factor. C all over x plus 2 to the power 1 plus d all over x plus 2 all squared. Right, so that is the first step. Simple to write down. What is the next step? We need to multiply by the denominator throughout. Okay. So let's see what happens when we multiply. So we got x cubed plus 5x squared minus 3x is equal to a into x minus 1 x plus 2 all squared. You got that? Plus b into x plus 2 all squared plus c into x minus 1 all squared times x plus 2. You got that?
Yes.
And then plus d into x minus 1 all squared. So we multiplied on both sides. We got rid of the fraction. Now we can use substitution because we have values here. We look at this factor. We can substitute a value that will result in the factor and everything multiplied by that factor being 0. What is that number? 1. Okay. So if I let x equal to 1, let's see what happens. So we're going to have 1 plus 5, which is 6, minus 3, which is 3 on the left. Here I'm going to have a 0. Here 1 plus 2 is 3, 3 squared is 9, so that's 9b. Here it will be 0, and the last one will be 0. Okay. So therefore 3 over 9 is equal to b, so therefore b is equal to 1 over 3. You got that? Right, what's the next value to substitute? Minus 2. So let x equal to minus 2. So on the left hand side, let's see what we get. So minus 2 cubed, that will be minus 8. Minus 2 squared is 4 times 5, that will be 20. Minus 3 times minus 2 is plus 6. Alright. Minus 2 plus 2, 0 there. Minus 2 plus 2, 0. Minus 2 plus 2, 0. Minus 2 minus 1, that's minus 3. Minus 3 squared, positive 9, so that's plus 90. Can you see it's unnecessary to show every single step here? Right, so that's why it takes very long to work it out. So this is how you should be doing it. So now on the left hand side, what do we have? 20 plus what's that? Minus 20, that's 12. We got 18 on the left hand side is equal to 90. Is that right? Right, so therefore 18 over 9 is equal to D. So therefore 9 times 2 is 18, so D is equal to 2. Now we've ran out of values to substitute that will result in zeros basically. Factors of zeros and us getting our answer quickly. What can we do? What values can we substitute?
1.
We can continue with substitution, or there is another technique, but I will deal with that when we deal with number 6. Yeah? Let's continue with substitution. If we continue with substitution, we're going to end up, we only found 2 out of the 4 constants. You follow? Any other 2 values that we will substitute will not give us the answer. We will end up with 2 equations, with 2 unknowns. We will have to work them out simultaneously. That is one way of working. Let's just continue with that for now. Okay, then with the next example, I'll show you the other technique. So choose any value you feel like, but don't make it very difficult. Okay, make x equal to, let's choose 0. Let's see what we get when we choose 0. Alright, so we got 0, 0, 0 there. You follow? If I substitute x is equal to 0, 0, 0, 0. So 0 on the left. Here you need to be careful. So if I put a 0 there and a 0 there, that will be minus 1. 0 plus 2 is 2. 2 squared is 4. 4 times minus 1 will be minus 4a. 0 plus 2 is 2. 2 squared is 4. Plus 4b. So there's a 0 here. 0 plus 2 here is 2. 0 minus 1, that's minus 1 squared is 1 times the 2, which will be plus 2c. 0 minus 1 is minus 1 squared, which is 1 times d, which is d. Alright. So what do we know? We know what the value of b is and of d. So 0 is equal to minus 4a plus 4 times your b plus, what else do we know there? D. Okay, so that's plus 2c plus d. So what was b? 1 over 3. And d is 2. So we have our equation 1. We just need to keep our unknowns on one side. Alright, so let's see what happens here. We got 0 is equal to minus 4a plus, we got 4 over 3 plus 2c plus 2. Okay, let me take these unknowns to the left hand side. So it's going to be a positive 4a minus 2c is equal to 4 over 3 plus 2. That will be 4 plus, that will be 10 over 3. Am I right? That is equation 1. We need our second equation because there are 2 unknowns here. There are 2 unknowns, we need 2 equations. 3 unknowns, 3 equations. So we chose 0. Give me another easy value to substitute here. Minus 1. Okay, let's try minus 1. Okay, if I'm using minus 1 now, so plus 3 on the left hand side. You follow that? Minus 1 to the power 3 is minus 1. Minus 1 squared is 1 times 5, which is 5. Minus 3 times minus 1 is plus. Let's deal with the right hand side. So now we are substituting minus 1. So 2 minus 1 is 1. 1 squared is 1 there. Minus 1 will give me minus 2. So this will be minus 2a. Here, 2 minus 1 is 1. 1 squared is 1. So that will be plus b. Here now. 2 minus 1 is 1. So we know that's a 1. Minus 1 is minus 2. Minus 2 squared is, so that's plus 4c. Minus 1 is minus 2. Minus 2 squared is 4, so that is plus 4d. So what must we do? We substitute for b and d and get our equation 2. So here 5 plus 3 is 8 minus 1, which is 7 on the left. We got minus 2a plus b, that's plus 1 over 3, plus 4c, plus 4 times d, which is 2. Alright, so now, let's see what happens here. Let me take my unknowns on the left again. So that will be a positive 2a minus getting the minus 7, I took the 7 to the right hand side. Can you see that? So now, so therefore, I have 2a minus 4c is equal to, I know that 8 minus 7 is 1. So basically 1 is 3 over 3 plus 1 over 3, which is 4 over 3. So, this is my equation 2. So now I got simultaneous equations. I need to solve for a